In this video, we're going to start off with an introduction to functions in Math 20-1. And this is our part 1 video inside of functions, and later on we're going to do the rest of the videos and cover up everything that we need to know about functions. So let's get started with this introduction video. So starting off, to understand what a function is, we first need to understand what a relation is. So a relation is a type of connection among two collections of things. So for example, we're going to take the example of the relationship between a city and also a country. So let's just say that we have a set A, and inside of this set A there is different cities. And the different cities are New York, Toronto, and Tokyo. And then for set B, we have the different countries. And the different countries we have is USA, Canada, and Japan. So what is the relationship between these two? If we are to check, the relationship is that the cities are connected to the countries. So for example, the city New York is connected to the country USA. And then for Toronto, the city Toronto is connected to the country Canada. And Tokyo, the city Tokyo is connected to the country Japan. So this is what a relationship basically is. It's a type of connection that is among two different things. And in this example, we saw the relation between a city and a country, and there's many more different types of relations as well. So moving on, now we're going to talk about functions. So a function is basically a relation where every input value x is connected to exactly one output value y. And sometimes these values x and y can be different also, but in this case we're going to take the example of x and y. So basically every input value which is from x is connected to only one output value, for which is y or whichever variable you have. So a function is basically just a special type of relation. And now let's just see if we can determine if the following relation is a function or if it's not a function. So inside of this table here, we can see that there is the x side and also the y side, and the values that we have on the input, which is the x side, is 2, 4, and 6, and the output values we have is 2, 5, and 3. So here we can see that the 2 in the input is connected to the 2 in the output. And then for the 4 is connected to the 5, and 6 is connected to the 3. So in this case, this relation would be a function because for every input value x, there is only one output value y. So in this case, we have 2 is 2, we have 4 is 5, 6 is 3. So for every x value here, we have a different and only one y value. So this is a function, and this is because every value of x is connected to exactly one value of y. So if there were to be multiple different values of y for the same x, then there wouldn't be a function. And we're going to look at some more examples in the upcoming slides. So for this one, let's determine if this following function is a relation or not. So in this case, we have in the left side, and in this case we have in the input side 1 is connected to 7, 3 is connected to 4, and 5 is connected to 4. So take a moment to pause the video and try to solve this question by yourself, and in a few seconds once you're done, we're going to go over the solution. So for the answer for this one, we can see that this one will also be a function, and this is because there is still only one output value y for every input value x. So this is a function, and this is because 3 is connected to only one value, and 5 is also connected to only one value. We can see that 1 is connected to one value, which is 7, 3 is connected to one value, which is 4, and also 5 is connected to only one value, which is also 4. So it's okay even though they are both connected to the value of 4, that's completely fine, as long as there's only one value that's connected. But if it were to be on the x side, if the x was connected to multiple, if the one y was connected to multiple x's, then that's when it would not be okay. So in this case, this is a function. So moving on, determine if the following relation is a function or not. And in this case, we have 8 is connected to 7, 6 is connected to 4, 4 is connected to 9, and also 4 is connected to 5. So for the answer for this one is not a function. And this is because 4 is connected to both 9 and also 5. So remember, a function is only when every input value x is connected to one output value y. So in this case, we have multiple input values of x connected to different y values. It's not just one output. So this is why this is not a function, and the previous ones that we saw were a function. So now how can we represent functions? So there are many different ways to describe a connection among things such as a diagram, table, equation, or graph, and also mapping too. So if we look at each one of them one by one, this is how they look like. So first of all, there's a diagram. So we already saw how the diagram would look like. It's basically just with an arrow and the input on the left side and the output on the right side. And then for the next one we have is a table. So the table values, where you have the input in one side and then the output on the other side, and then you just put them out in a table format. And then another one is an equation. So this is how the equation one would look like. And then there's also mapping. So mapping is where you have these two different circles and then you draw arrows to which one it's connected to. And then finally there's also the graph. And the graph is where you actually plot the function onto the graph. So these are the different ways that you can represent functions. And a function could look very different depending on how it's actually represented. So these are the different ways that we saw. So in order to call something a function, it must satisfy the definitions of, first of all, every value of x is connected to only one value of y. So as we saw in the previous questions, every value of x has to be connected to only one value of y. If there's different values of y connected to one x, then it is not a function. And for the second part, it is okay if multiple values of x are connected to the same y value. So if we have, for example, 3 in the input, if we have 3 and 4, and they're both connected to the output of 5, that's okay, because they have different y values. And that is okay because each one of them have one y value. But if there was multiple x's that were the same connected to different y values, that's when the function would not be an actual function. So now moving on, you can also do something called a vertical line test. So in order to determine if a graph represents a function, we can check using a vertical line test. And this is basically how a vertical line test looks like. It's where you plot your function onto the graph, and after that, you just do a vertical line test depending on what your x value is. So for example, if we look at this first one here, we are just choosing the x value of 3. So then we just draw a vertical line. And then in order to determine if this is a function or not, if there's only one y value for every x, then that would be a function. So in this case, we can see that there's only one y value in this whole entire x column. So that means that this is a function because for every x, there's only one y. But in this case, if we look at this one, if we do this vertical line test, we can see for the same x, we have multiple different y values. So since there's multiple different y values, this cannot be a function. So in this case, the first one's a function and the second one is not a function. So if any vertical line only crosses the graph once, then it's a function, and if it crosses twice or more, then it is not a function. So that summarizes everything for the introduction to functions. So thank you so much for watching from Try to Be Useful, and we'll see you in our next functions video.